Approximate all real zeros for the following polynomial. Round your answers to 2 decimal places. So the key word here, approximate, tells us that we aren't going to be able to find these exactly. And exact answers would have square roots, the constant I, things like that. So that we can approximate means we can use our calculator. How do we use our calculator for this? Well, here's what we do. First thing we do is graph the polynomial. Because if we have a zero of this polynomial, it should cross the x-axis if it's a real zero. And it does say approximate all real zeros. So there should be at least one that crosses the x-axis. So let's see what happens when we graph it. And I'm going to make sure I'm in the standard viewing window, so I'll hit zoom and 6 for that. And there's a decent picture of this polynomial. Now, every time the graph crosses the x-axis, I have a real zero. So where are those located? Well, it looks like somewhere close to -1, +1, and possibly at 2. But the thing is, we can't, this graph isn't going to be accurate enough to really determine for certain where those are. Oh, that's not 2, that's probably 3. Anyhow, the way we will determine these is through approximating using the calculator. So if you hit second and the trace button, tell you what, let me bring this up in a larger screen for you. Then you'll see this menu here. And there's a lot of different things you can calculate based off of a graph. But what we want is a 0. Now, for it to be able to do a 0, what we need to do is tell it just about where that thing is. Okay? So it says here pick a left bound and a right bound. The left bound has to be something that evaluates to, if it's negative on one side, it needs to be positive on the other. So the 0 needs to be in between a left and right bound. So it looks like it's at about -1 point something. So let's say the left bound is -2 and the right bound is 0. All right, so it's somewhere in between those values. The initial guess just starts the calculation. Just put your cursor somewhere close to the 0, and then it will run its program and come up with the best approximation it possibly can, accurate to as many decimals that it's showing. So in this case, -1.34. That's what we'll use because it did say to round to 2 decimal places. So we have -1.34, and there are 2 others. Now it looks like they're at 1 and 3, but again, we can't be certain of that. So let's hit second calc again, see what we come up with. So the second 0 is certainly between 0 and 1, or sorry, 0 and 2. And then my initial guess, I'll use 1. All right, so it's close to 1, but it's not exactly. So it's 0.89. And then lastly, we have one more 0, and it looks like it's close to 3, but again, let's not just assume that that's the case. And we'll say it's somewhere between 2 and 4, and guess that it's at 3. All right, so it's really close to 3, but it's not quite 3. It's 2.95. So there are the approximations to the 3 zeros of this polynomial.